In this video, we discuss the quadratic equations, and then we talk about modeling with quadratic equations. The quadratic equation is an equation that can be written in the form ax squared plus bx plus c equals 0, where a, b, and c are real numbers, and a is not equal to 0, because if a is equal to 0, then the first term will disappear and we get an equation, a linear equation. Now let's take some examples of quadratic equations. 2x squared plus 3x plus 1 equals 0. This is a quadratic equation. Look at the power. The highest power is 2. A is not equal to 0. We have 2 as a leading coefficient. So this is a quadratic equation. Another equation, x squared equals 9. This is a quadratic equation because we can rewrite this equation as x squared minus 9 equals 0 if we bring this to the left hand side, or subtract 9 from both sides. So what is a in this case? A is the coefficient of x squared is 1. B is the coefficient of x. The coefficient of x is, we don't have x here, so the coefficient is 0. C is negative 9, the constant term. Similarly here, A is 2, B is 3, and C is 1. So these are examples of quadratic equations. And we know that the graph of a quadratic equation looks like this or this. It's called parabola. If the leading coefficient, I mean a, if a is greater than 0, then it's open up. The parabola is open up. If a is less than 0, then the parabola is open down. But here in this section, we focus on quadratic equations rather than focusing on the graphs of these of quadratic functions. Now, how to solve quadratic equations? We have in this section, we have 3 main methods to solve quadratic equations. The first method is called solving quadratic equation by factoring. That means we factor the quadratic equation and then use some properties to solve that equation. In order to do so, we need a property that is called zero factor property. The zero factor property says if a, b are real numbers, I mean by real numbers all numbers that you dealt with or studied previously. Can be positive 1, negative 5, 0.001, any fraction, any rational function, and any irrational function. Pi is a real number. So all these are real numbers. So any number that you can imagine is called real number. I mean the numbers that you already studied before. There is another set of numbers is called complex numbers, but we don't study it in this course. So these are real numbers. Then if a times b equals 0, if the product is 0, then either a equals 0 or b equals 0, or both of them both equal 0. And this is a very important property. This is called zero factor property. Let's take an example. For example, if we want to solve x squared plus 5x plus 6 equals 0. This is a quadratic equation. We want to solve it by factoring. Now we factor this expression, the left-hand side. So we write xx, because x times x is x squared. And then we find two numbers where the sum is the middle number, the number 5, and the product is the constant term, 6. What are the two numbers? The two numbers are 2 and 3. And the sign is positive. 2 times 3 is 6. 2 plus 3 is 5. Now we apply this property. We apply the zero factor property, and that if this is A, this is B, A times B is equal to 0. That means either x plus 2 equals 0, or B, which is this is A, this is B, or B equals 0, or both of them. So we solve each one of them. So x plus 2 equals 0, or x plus 3 equals 0. And then we solve each linear equation. So we solve them separately. We have x equals negative 2, x equals negative 3. So we use the zero factor property to solve the quadratic equation by factoring. So the solution set is the set that consists of negative 2 and negative 3. Let's take another example. If we look at the first example, A in this case is 1. A is the coefficient of x squared, is equal to 1. And that means we can solve the problem easily and by factoring the expressions and then applying the zero factor property. Now, if we have a coefficient other than 1, I mean the leading coefficient is not equal to 1. Here it's 6 plus 7x minus 3 equal to 0. We want to solve this by factoring. Now, how to solve this? We have a problem here. The leading coefficient is not equal to 1. So how can we solve this type of problem? There are different methods, techniques to solve this, and you can take a look at the YouTube to see some different methods to solve this. But I used to use the following method. So we open two parentheses and divide by the leading coefficient 6. And we put 6 here and 6 here. And then x squared, we put x here and x here. If we look at this, x times x is x squared. 6 times 6 over 6, we can cancel 6 with 6, and we get 1, 6. Okay, and then we find two numbers where the sum is the middle term, it's 7, and the product is a times c. A times c, I mean negative 3 times 6, or 6 times negative 3, which is negative 18. So the sum is 7, the product is negative 18. What are the two numbers? We need to think about two numbers. If we use 6 and 3, this multiplication product gives 18, but the sum cannot give 7. So let's try other numbers. We can try 9 and 2. 9 times 2 is 18. And if we choose positive 9 and negative 2, the product is negative 18 and the sum is positive 7. So that's it. And then we try to simplify. We need to cancel the denominator. So look at the first expression here. You can take 3 as a common factor, and we are left with 2x plus 3. You can distribute 3 to make sure that your answer is correct. And we can factor the second expression, so we can take 2 as a common factor, and we are left with 3x minus 1. And then this becomes 2 times 3 is 6 times this expression, 2x plus 3 times this expression, 3x minus 1, all over 6. And then we can cancel the 6 and get 2x plus 3 times 3x minus 1 equal to 0. And then we can apply the zero factor property. This is A, this is B. So we have 2x plus 3 equals 0, or 3x minus 1 equals 0, or both of them equal 0. And then we solve this, negative 3. So we get 2x equals negative 3. And then we divide by the coefficient of x to get x equals negative 3/2. This is one solution. The other solution can be obtained from the other equation. So 3x equals 1. And then we divide by 3 to get x equals 1/3. So the solution set is negative 3/2 and 1/3. Now, the second method, or the second property. The first property is we are still working on factoring, but we have some important property that's very important in many applications and many equations. So the first property was the zero factor property. The second property, B, is the square root property. The square root property. This property says if you have x raised to power 2, x squared equals some constant a, this is constant, this is any number, positive, non-negative number, then to solve this equation we write x without the square equals, and we replace that with plus or minus square of the right hand side. So please keep this in mind, how to solve this type of problems, because this is a very important class of problems and this is a very important property. For example, if we want to solve x squared equals 16, now we can apply the square root property. So we write x without the square and we replace this with plus or minus square root on the right hand side of 16. And that's plus or minus. What is square root 16? It's 4. So we have two solutions, 4 and negative 4. So this is the solution set. Sometimes we have more complicated expression, but we still can use the square root property. So we can use it for this type of problems. For example, x minus 4 all squared equals 12. So we can look at this. We need to get rid of the square here. So we write this without writing the square, but we replace this with plus or minus square root of the right hand side. The right hand side is 12. And we know that 12 is 4 times 3. And then we can distribute the square root. Square root of 4 is 2. Square root of 3 is just square root 3. So we have x minus 4 equals 2 square root 3, or x minus 4 equals negative 2 square root 3. And then we solve these equations. We get x equals 4 plus 2 square root 3, or x equals 4 minus 2 square root 3. So the solution set is 4 plus or minus 2 square root 3. Now that was the solution of quadratic equations by factoring and using the two properties, zero factor property and the square root property. Now the second method of solving quadratic equations is solving quadratic equations by completing the square. We'll take an example. Instead of explaining the method first and then taking examples, I will solve example directly so that you can understand the method from the example, from solving this example. So we want to solve x squared minus 4x minus 14 equals 0 by completing the square. Now the first step is to look at the coefficient of x squared. The coefficient of x squared must be equal to 1. I mean a should be equal to 1. If it's not equal to 1, then we need to make it equal to 1, as we will see from the next example. But for this example, a is equal to 1. The coefficient of x squared is 1. So first, we isolate the constant term. I mean, we send it to the other side of the equation. So we are left with x squared minus 4x equals, when we bring this to the right hand side, the sign becomes positive. And then we apply the following rule. We take 1/2 times the coefficient of x. We don't need to worry about the negative sign here. Squared. So 1/2 of 4 is 2. 2 squared is 4. This number will complete this square, because here we only have 2 terms. We need to have 3 terms in order to solve the problem, to bring the square from here to the square above the whole expression, like this problem. Okay, so we add this number before and after the equality. We can, on the right hand side, we either add it before or after the 14. So we can add it. We add it before and after the equality sign, or simple. So we have x squared minus 4x plus 4 equals 4 plus 14. And then if we look at the left hand side, this is called complete square. Now this is a complete square. If it's complete square, after completing the square, we can write it this way. We can bring the square from the power of x to the power of the whole parentheses, and we put x here, and we put the square root of 4, which is 2, and we put the sign of the middle term, equals the right hand side. The right hand side is 4 plus 14, which is for simplicity, I don't want to deal with square root of some numbers that doesn't have square root, natural square root. So let me just change this. This will not affect our method. So let's consider 14 is 12, not 14. I just want to replace it for simplicity. Okay, so when we add this to 14, we get 16. Now, if we look at this equation, we dealt with this type of problems here. It's very simple to this, so we can use the square root of property to solve this. So we write x minus 2 without the square here, and we replace it with a plus or minus on the right hand side of square root 16, which is plus or minus 4. So we have two equations. X minus 2 equals 4, x minus 2 equals negative 4, and then we solve these two linear equations. X equals 6 and x equals negative 2. So the solution set is negative 2 and 6. Now let's solve a problem where the leading coefficient is not equal to 1. So let's take another example. For example, if we want to solve 2x squared minus x minus 1 equals 0 by completing the square. So the first thing to observe is the leading coefficient of x squared. This is a is not equal to 1. So what should we do in this case? We divide each term by 2. So we get x squared minus 1/2 x minus 1/2 is equal to 0. Now the leading coefficient is 1. Now a is equal to 1, so we can complete the square. The second step is to bring the constant term to the right hand side. It becomes x squared minus 1/2 x equals 1/2, and then we complete the square by using 1/2 times b squared. So 1/2 times what is b? B is negative 1/2, but as I mentioned before, we don't need to worry about the negative sign since we have a square here. So 1/2 times 1/2 is 1/4 squared, which is 1/16. Now we add this number before and after the equality. So the equation becomes x squared minus 1/2 x plus 1 over 16 equals 1 over 16 plus 1/2. Now this is a complete square. The left hand side now is complete square because of this step. This step makes the left hand side complete square, and by complete square we mean that we can bring the square from here to here. And then x squared, what is the square root of x squared? Is x. What's square root of 1 over 16 is just 1 over 4, and the sign of the middle term is negative. Now the right hand side, we need to simplify this, so let's try to get a common denominator. So we multiply by 8. 8 plus 1 is 9 over 16. Now we can apply the zero factor property. So x minus 1/4 without the square becomes plus or minus square root of the right hand side, and that's plus or minus what's square root of 9? 3. What's square root of 16? 4. So we have two equations. X minus 1/4 equals 3 over 4. X minus 1/4 equals negative 3 over 4. Now we solve these equations. We add 1 over 4. X equals 1. 4 over 4 is 1 when we add these two. And here we add 1/4. So we get x equals negative 2 over 4, which is negative 1/2. So the solution set is negative 1/2 and 1. Now the third and the last method in this section is the quadratic formula. And many people think that this is the guaranteed method of solving quadratic equations, and this is one of the easiest, maybe the easiest method in general, because in many cases we may get a coefficient of x squared other than 1. 2x squared, 3x, or something like that. This type of formula, the quadratic formula, can solve any quadratic equation or determine if there is a solution or not. So if we have the quadratic equation x squared plus bx plus c, this is the standard form, then the solution is, or the solutions are, x equals negative b, negative the coefficient of x, plus or minus square root b squared minus 4 times a times c all over 2a, all over 2a. Okay, so we need to remember this when we apply the quadratic formula. Now we have three cases. Now look at the expression inside the square root. This is called discriminant. Why? Because this can determine number of solutions. If we have a quadratic equation, then we have at most two solutions. We may have two solutions, or one solution, or no solutions. But we can't have three solutions for the equation, for the quadratic equation. Okay, so depending on this, b squared minus 4 times a times c, we have three cases. If this is greater than 0, then we have two distinct solutions, real solutions. And if b squared minus 4ac is equal to 0, then we only have one solution, or sometimes called repeated solution. That means when we solve the equation, we may get x equals 1 and x equals 1. That means we only have one solution, x equals 1. Or b squared minus 4ac is less than 0, and that means we don't have a solution for the equation. So no solution in the real numbers. Okay, so these are the three cases. Depending on this expression that's called discriminant, we can determine number of solutions. Now let's take some examples. So if we want to solve x squared minus 4x plus 2 equals, let me choose simpler example, or the example that we just solved here, the last example that we solved here. This. We want to solve it using quadratic formula, so we want to solve 2x squared minus x minus 1 equals 0 using the quadratic formula. So we need to determine a, b, and c. This is b, -1, and this is c is -1. Now we apply the formula, this formula. So x equals -b plus or minus square root b squared minus 4ac all over 2a, and this is negative b. What is b? b is -1 plus or minus square root b squared -1 squared minus 4 times a is 2, times c is -1, all over 2 times a, 2 times 2. Now we have -1 is +1 plus or minus square root -1 squared is 1, minus times minus is a plus, 4 times 2 is 8 over 4, and this is 1 plus or minus square root 9 over 4, and this is 1 plus or minus 3 over all over 4. So we have two solutions, 1 plus 3 over 4 or 1 minus 3 over all over 4. This is equal to 1, and this is equal to -1/2. So the solution set is -1/2 and 1, as we've seen from the previous example when we applied the completing this square. We should get the same answer. Now, if we want to use the discriminant, to determine number of solutions, of first 5x squared plus 2x minus 4 equals 0. We don't want to solve, but we want to determine number of solutions. So we find b squared minus 4ac. And this is, what is b squared? B squared is 2 squared minus 4 times a is the coefficient of x squared times c is the constant term. And this is 4 minus times minus is plus. 4 times 5 is 20 times 4 is 80. So this is 84, which is greater than 0. If the discriminant is greater than 0, that means we have two distinct solutions. Let's take another example. If we have 2x squared minus x plus 1 equals 0, we apply same formula. B squared minus 4ac equals, what is b squared? -1 squared minus 4 times a is 2, times c 1, and this is 1 minus 8, which is -7, less than 0, so no solution. No solution because the discriminant is less than 0. Let's take another example. If we have x squared minus 10x plus 25 equals 0, then b squared minus 4ac is, b squared is -10 squared minus 4 times a is 1 times c is 25. This is 100 minus 100, which is equal to 0. If the discriminant is equal to 0, then we only have one solution. Now the second part of this lecture is section 1.5. In 1.5 we are talking about modeling with quadratic equations. So let's take an example. We have a piece of property that has the shape of a right angle triangle. the longer leg is 20 meters longer than the length of the shorter leg. Now the hypotenuse is 10 meters longer than the length of the longer leg. The question is, find the lengths of the sides of the triangle. So this is a modeling problem, so we need to remember that the first step is to read the problem, and then after reading the problem we assign a variable. Now, how to assign a variable? We can graph this problem. We start with the smallest quantity. The smallest quantity is the shortest leg. So we can consider this as x. This is a leg, and this is another leg. And this is the hypotenuse. The hypotenuse is the opposite side, the side that corresponds to the right angle of the triangle. So if we consider the shortest, the length of the shortest leg, we consider it as x, then we have the longer side, which is this side, is here. The longer leg is 20 meters longer than the length of the shorter leg. So it's 20 okay, so it's longer than twice. I will add twice here, twice the length of the shortest length. So twice of the shortest length, that means 2x. 20 meters longer, we need to add 20. So 2x plus 20, this is the length of the longer leg. Now the hypotenuse is, here we have an information about the hypotenuse, is 10 meters longer than the length of the longer leg. The longer leg is 2x plus 20, and it's 10 more, or 10 longer, so we need to add 10, and this is 2x plus 30. This is the length of the hypotenuse. Okay, so after determining these quantities, we can formulate an equation. We write the equation. So we use, since we have right angle triangle, we use Pythagorean theorem. And this theorem says the hypotenuse squared is equal to the sum of squares of the two legs, or to the other sides. So this is 2x plus 20, the hypotenuse squared, equals the sum of squares of the other two sides. I mean x squared plus this side is 2x plus 20 squared. This should be 30 because it's the hypotenuse. Okay, and then we simplify. We get 4x squared plus 120x plus 900. I applied the following formula. A plus b squared is equal to a squared plus a 2ab times plus b squared. The square of the first term is 4x squared plus 2 times the first times the second. 2 times 2 is 4 times 30, 120 times x, plus the square of the second square of 30 is 900 equals. The right hand side is x squared plus, now we apply same formula here, square of the first term is 4x squared plus 2 times a times a, 2 times a times b, 2 times 2x is 4x times 20 is 80 x plus 20 squared is 400. Okay, now we can subtract 4x squared from both sides, and then we get 120x plus 900 equals x squared plus 80x plus 400, and then we subtract this expression from both sides. So this becomes 0 equals x squared. Now 80x minus 120 is negative 40x. 400 minus 900 is negative 500. Now we got a quadratic equation, so we can solve it by factoring this expression. So we have x here. We find two numbers where the sum is negative 40 and the product is negative 500. The two numbers are negative 50 and 10. If we find the sum is negative 40 and the product is negative 500. So this is equal to 0. So we apply, remember this is A, this is B, so we can apply the zero factor property. X minus 50 equals 0 or x plus 10 equals 0, and then we add 50 to both sides. Here we add negative 10, so we get x equals 50, x equals negative 10. Since we are talking about sides of a rectangle, side cannot be negative. That's a length, cannot be negative. So the only correct answer is x equals 50. Now that's the solution. So what are the lengths? The lengths now they solve the equation and then we write the answer. The answer is the shorter one is 50 and the longer one is 2 times x, 2 times 50 plus 20, which is 120, and the hypotenuse is 2 times 50 plus 30, which is 130. So these are the lengths of this rectangle. Now if we triangle, if we want to check our answer, we can apply the Pythagorean theorem again to show to determine if this is correct or not. So if we square 130, this should be equal to 50 squared plus 120 squared. Now the last example. We have a projectile that's launched vertically according to the equation s equals negative 16 t squared plus 100 t. This is the distance, which represents the length, and this is t time in seconds, for example. And initial velocity, the initial velocity is 100 feet per second. neglecting air resistance. Now the first question is, after how many seconds will the projectile, be 50 feet above the ground? So this represents distance or length. So this is S. So S is equal to what? Negative 16t squared plus 100t, and we're asked to find how many seconds. That means we're asked to find t. So we need to solve this. S is 50 equals negative 60t squared plus 100t. Now we bring these to the left-hand side to make t squared, the coefficient of t squared, positive. So we get 16t squared minus 100. When we bring them to the other side, we change the signs, and we already have 50 on the left-hand side. This is equal to 0. We can simplify by dividing by 2 to get 8t squared minus 50t plus 25 equals 0. And then we apply the quadratic formula. Negative b, or negative b is negative 50, plus or minus square root b squared minus 4 times 8 times 25 all over 2 times 8. Now simplifying, we get 50 plus or minus square root 2500 minus 800 all over 16. And then we get 50 plus or minus square root 1700 all over 16. And using the calculator, we get two answers. 50 plus square root 1700 over 16. This gives approximately 5.70. And 50 minus square root 1700 over 16, this gives me approximately 0.55 seconds. Now, after how many seconds will it be 50 above the ground? It will be 50 above the ground twice, because when we project this, it will return to the earth. If this height is 50, then this happens at time equals 0.55 seconds, and it happens here when it returns to earth, to the ground. S is, or time is, after 5 seconds 0.70. It has the height S equals 50. Now part B, how long will it take the projectile to return to the ground? So we want to determine S or T, how long it takes to return to the ground. So that means we're asked to find T as well. To return to the ground, what does that mean? That means the length or the distance is 0. S equals 0. So we solve this equation. 0 equals negative 16t squared plus 100t. This is the original equation, so we just replace S with 0. And then we solve this equation. Let's bring these to the left-hand side to get positive coefficients of t squared. And then we can take for t as a common factor. And then we apply the zero factor property for t equals 0 or t minus 25 equals 0. We divide by 4 here to get t equals 0. And we add 25 here to get t equals 25 seconds. So 0 second is not acceptable because we are talking about returning to the ground, and that cannot be at time 0. Time 0 is the time when we started projecting the projectile, the object. So this cannot be the solution. The solution will be t equals 25. Here we have 4. Sorry, here this should be 40. So 40, so we divide by 4, which can be written as 6.25 seconds. So this is the correct answer.